Good evening, friends. Welcome to Eason Academy. And we are discussing about embedded programming as a part of embedded system programming. So I'll explain to you later what is the difference between embedded programming and embedded system programming. This one single word will make you lots of difference. And today we are discussing about session 3. We are into session 3. We are going to discuss about 7-segment display. So the last session, we had discussed about LEDs. Okay. Currently, we're going to discuss about 7-segment display. So before we get into 7-segment display, let us have a small walkthrough on LEDs. Okay. If you have any doubt also, you can ask right now. I have done it. Yeah, I have uploaded. You have not seen it? Oh, somebody has asked, I have not uploaded. I think I have uploaded last session on Drive. Let me check it up. Okay. I'll check it up after the class. If you have not done it, please let me know. I normally do it immediately after the class. I think I would have done it. If you have not, please. So, yeah, I have uploaded. Yeah, I have done it. Let me check. Coming under the ESP section, I can check it even right now. Please, somebody give me a minute, because somebody told me I'm not. It's not there. That's not right. I'll give me a minute. I'll check it up before I proceed further. Yeah, it is there. Yeah, I've checked. Okay, thank you. I've checked and it's there. Okay, that's fine. Every day evening at the end of the class, I upload the videos. So don't. Normally I have the practice of that. So let us. If you have any doubt on the last session on LED, you can ask me. I'll just summarize it because there is no difference between that and today's session. That's why I'll summarize it. What we discussed and what we're going to discuss. So what we discussed was very simple. We had an LED and we are controlled the LED using your microcontroller. And we have connected this to the ground because it's a LED. And the LED spec says you're supposed to give 2 volts, but we are giving 5 volt because we are using a microcontroller of 5 volt. It's a standard. So generally the worldwide they use this 5 volt. We also use it 5 volt. So this is 5 volt, this is 2 volt. So that will spoil the LED. So we add a resistor. The resistor will drop 3 volts. So 3 plus 2 is 5 volt. 3 volt plus 2 volt is equal to 5 volt. Am I right? Now, how do you find the value? Okay, that's a trick. Since this is 3 volt and this LED can withstand up to 10 milliampere. So you apply 3 volts and the current is 10 milliampere. Both are in series. So 3 volt divided by 10 milliampere. So 3000 millivolt divided by 10 milliampere. So ampere volt is ohm, milli strike, 10, so 300 ohm. This is what we discussed on the class. So we can find the resistor 300 ohm. You don't think what they will ask you in the interviews or test or somewhere, just to confuse you, they will put here 3.3 volt. They will give a supply of 3.3 volt. And if you say if they ask you what is the value of the resistor, then you will know that it's always 300 ohm. That is wrong. Now You apply 3.3 volts, 2 volts. So the drop is 1.3 volt. So 1.3 volt divided by 10 milliampere is 1300 millivolt. So it is 130 ohm. Understand that. So the resistor varies based on the supply voltage of the microcontroller or the output pin voltage of the microcontroller. That is one. Second thing, this is the first one. So you should know that whenever you connect a LED, but that's always not true. Not all the LEDs are 2 volts. Some LEDs have 4 volts. If you take blue color or white color, so the across the voltage is 4 volts, not 2 volts. So please understand that. So don't always think that it's only a 2 volts. So we assume red or green. Red or green. These both LEDs are 2 volt. That's why I am assuming now. Also, the one more thing. This microcontrollers have multiple ports. And we are talking about 8-bit microcontrollers. So all the port size are 8 bits. Assuming that all the ports are 8 bits. And each port has about 8 pins. Am I right? And what they have done is the port can be output or input. They give an option. Any pin can be input, any can be output. You can do that. That's why all the microcontrollers have the feature. So what they have done, this is a beauty. Each port has 3 addresses. 3 addresses. One is direction register. One is out register. One is in register. This is common in all the microcontrollers, please understand. But nothing great. See, you have a name for Balaji. Am I right? Like that, the port is having a number. That's the only thing. When I say address pin, that's a number. Nothing more than that. Don't get confused about the address. Yeah, direction will tell you that whether this pin is going to be output or input. You decide. Let us say that you want out of these 8 pins, these 4 pins are going to be output. These 4 pins are going to be input. And this is bit 0, this is bit 7. So 7, 6, 8, 5, 4, 3, 2, 1, 0. This is LSB, this is MSB. Always understand. 0 is always LSB and 7 is MSB. Now, what will I do is that this to be out. Out means all 1. In means all zeros. That means that the value is 0 in 0F in hexadecimal. So what I write here is, I say char star dir. Dir is equal to 0x30. This address given by the manual that we discussed. I showed you that each microcontroller have a different addresses. Then I put star dir is equal to 0x0f. Please understand. I will. If you want, I can share you once again that thing. That is very important for us to understand. I've shared the data sheet for you that day. I've shown a data sheet saying that, see here, the pins are having, okay, the pins are having, this is one of the data sheet called Atmega 2560, because we are using that Atmega controller on the board to display, but all are same. See, there are thousands of cars in the market, understand, but you will drive only one car. If you go to the driving institute, if you ask them to teach them on BMW, they don't do that. But they know that you learn any microcontroller, any car, you can drive any car like that here. These are common in everybody. I will compare this. And if I have a time today evening, at the end of today evening, I'll compare this with the ARM processor. What is there in the ARM? Okay, now you see here, port F is having data register, that's all out. And port F, data direction register. And port F, input pin address. Understand? So, this is the input address, and this is the direction register, this is output register. There are only three. And this guy is 31. Out is 31. Out is 31. And direction is 30. And sorry, direction is 30. And input is 2F. Understand that? You understand now? So that's the way it works. So if I do that, I can make it. So for example, you see that there are so many ports. Port A, port B, port C, everything. So each port is having different address. That's all. Let us say you connect the LED. See this one. Let us assume that this is port A. This is port B, port C, port D. Each port is 8 pin. If you connect a LED or motor or anything on anywhere, that is there. I've shared a data sheet. There's a directly I've shared with my group data sheets. The data sheets you have with all these things. I've already shared. I'll check that also. I don't know. I do it very ritually, these things. I've see here. You may be seeing the screen. I've shared on our group that data sheets. Okay, you would have got it. Even I've shared the LEDs also. Okay, so no, what I'm trying to say is that port A is having an address of 0x21, 0x22, 0x20. That's what they have written. See here, this is what pin input register is 20, direction is 21, output is 22. Then port B, the number changes. So if I put this of 30, sorry, 22, then you get port. See, what I'm see, please understand, this is very important. I don't want to do. I'm not in a hurry to move. I don't mind to spend about few extra hours on the weekends if you are free. I don't mind. I'm free. But understand it very clearly. A microcontroller can have n number of ports. For example, you take this microcontroller, this alone, this 2560 from Atmega. This microcontroller is having, already I've shown that. See here. See, port A to port K, they have. Port A to port K. I'll show you here itself on the diagram also. See here, this is called block diagram. So they have port A, port B. See here. Port B. Okay. Port C, port D, and E may be somewhere else. Port E, port F, port G, and G. See that how much they have. H, I is not there. Instead of J is there. K is there. L is there. See that? How many ports? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 ports are there. Understand? You understand this? That means that this microcontroller, see, all the pins are also shown here. See that? You can see that. This is IC. This IC is having so many pins. How many pins? 100 pins. And see, pin number 2 to pin number 9 or PE port. Pin number 12 to pin number 17, say 18 or PH port. And PB port, pin number 19 to pin number 25. Like that, they have all the ports are there. So this is what the thing you have to understand. That means that, see here, PF, PK, PA. So all the ports are there. Understand now? So that means that I have, if I buy this chip, 100-pin chip, in the 100-pin chip, I have, how many ports are there here? A, where is he? A is there. I have shown A is here. And I have shown, where is B? B is there. And C is there. And where is D? D is there. And E is there. F is there. Where is G? Your G is here. See here. So like if you just read the pins, you just write it down what pin, what it is, then you will understand. And maybe as some reason they may be having some of the ports may not be 8 pins, some internal usage. For example, you see here, see that port G is having 0 to 5. That means that the 2 pins they use internally for some other operation. It's not out. All the others are 0 to 7. Always understand LSB to MSB. All are 8. Only this one is 6. That's fine. So think of it. Yeah, I've explained. But the problem is today also we need this. That has to be understood very clearly. So we have a microcontroller. We have a microcontroller which has so many ports. So many ports. Each port can have their own addresses. And each pin can be input or output. And each port is having 3 addresses. One is called direction. One is called output. One is called input. Understand? One is called direction. One is called out. One is called in. Okay. So please. Now we can connect the LED, the pin, like this, a resistor and a, you should know which, see, I told you each port is having 8 pins. Let us say I connected the pin on the 0, 1, 2, 3, 4, 5, 6. I connected on second pin. I connected the LED on second pin. Now I'll write a program, CHAR star DAR. And DAR is equal to 0x30. And star DAR is equal to 0x. This is 0, 0, 0, 0, 0, 1, 0. That is 4. I make only that pin as output pin. All the other pins I make them input. Because I'm not using them, I better use the input. Then I put star out. Out is equal to 0x31. Star out is equal to 0x04. Now, if I run 04, I make the pin 1. See, understand the difference. The DAR set the direction. It is not actually outputting. But here I'm outputting. Correct. Only pointer. Pointer only. Because everything is address, everything is pointer. You should know this. If you don't know this, then you're gone. They will give you memory map. They will tell you what is address. You better understand this. This is the most important. In microcontroller, better you know this pointers. If you don't know pointers, then you're gone. You cannot write to them. If they will tell you that this port address is 0x80. How do you write them? You better use pointers. There's no way. Pointer is the only thing used in embedded system programming. Any address, you can write any value. That's a pointer. Any address, you can write any value. That's nothing more than that. So, if I no, this is 8-bit. What is output 3113? I don't know. I'm not understanding that. This is not about microcontroller. It's about C programming you're asking here. This is 8-bit. You don't see anywhere output at all. Output is only LED. You don't see it on monitor or anything. Okay, now let us do this. Please explain once again. That means that every port can be configured as output or input. That is done by this guy. This line, these two lines, which I've written here, or these two lines are for configuration. Please understand, these don't get confused between these two lines and these two lines. This is actually outputting, and this is only configuring. If we make this one as a 0, 0, that means that I make all the ports as the input ports. If we make this star direction as a 0, then I make all the ports as an input port. If you connect a LED here, if you say out 31, out is equal to 0, 4, the LED will not glow. The LED will not glow. The address comes on the address lines. That's all. Whatever address you give, you put, microprocessor is having address and data. If you put star address, that comes on the address line. That's it. Nothing more than that. That depends on address. Your address could be 16-bit or 20-bit or 24-bit or 32-bit. That's the thing. So based on that, your address can be done. So that you have to watch my number systems video once again. That I explained about how to do it on the binary to hexadecimal, hexadecimal to binary. Address is the one which is having a name. Address is a name. That's all. Address is a combination of bits. It's a name. Okay, you have a name. I have a name. That's it. So if somebody calls Balaji, it's a combination of alphabets. Here, a combination of ones and zero. Every combination is having that. That I've explained about in the microprocessor class. So if you just go and watch the microprocessor class videos. So now let us have a thing. We connect the LED now. It looks to be very simple to you. Am I right? Normally in our houses, we take a bulb. We apply here 230 volts through a switch. And we connect it to neutral or negative. That's the way we do that. Now, here, this LED can be connected in two ways. That's a trick. The LED can be connected in two ways. See here, the LED can be connected like this. The other pin, I could connect the LED like this. Please understand there are two ways I connect the LED. There are two ways I connect the LED. One way is this way. Other way is the other one. Okay. The one way you connect the LED down, other way I connect the up. Understand? What will happen here? Here, if I give here 5 volt, this is 5 volt, this is 5 volt. Difference is 0 volt, no current. So LED will not glow. Here, if I give 0 volt, this is 0 volt. The difference is 0 volt, LED will not glow. But here, if I give 0 volt, this is 5, this is 0. So the LED will glow. Am I right? The LED will glow. Now the other one, I give 0 here. If I give 5 volt here, this is 5, this is 0. Then the LED will glow. This is the difference. So please understand, if there is no potential difference, then the LED will not glow. That's a trick. So this is called, if I give here 5 volt, then the difference is 0. So the LED is reverse bias. So don't think that only 5 volt will make the LED glow. You know what they call this one? This one, they put the LED in the common anode. Here is called cathode. They make it as a cathode as a ground, and anode point they give a voltage. Here they make the anode cathode as a pin, and anode they give the voltage. Okay, there are 2 ways you can connect the LED, but the resistor is same. The resistor is same. There is no difference on the resistor. Okay, there are 2 ways you can connect the LEDs. Depends on the requirement. No, this is not input or anything. Don't worry. This pin and this pin are independent. This is not input. Here the current is coming input. This is actually output. If you say here, write a program, CHA star out. Out is equal to 0x31. Star out is equal to 0x00. That means that this is pin number 0, 1, 2, 3, 4, 5, 6, 7. You make all the pins 0 now. But this LED will glow. This LED will not glow. If you make 0xFF, you make all the pins are 1. You make all the pins are 1. But this is 5 volt. This is 5 volt. This LED will not glow, but this will glow. Please understand that how we connect the LEDs. There are 2 ways. Now, people have found a mechanism that how do I connect these LEDs to display something different numbers? Okay. Yeah, it takes only 8-bit because 8-bit is only CHAR. If you attended the C class, I told CHAR is 8-bit. And we are discussing about only 8-bit microcontrollers. CHAR is only 8-bit. Or you can use int 8_t, whatever, both are same. But this or this, both are same. There's no difference at all. So we are using only 8-bit microcontroller. So we're using only CHAR. Don't use int. All the ports are only CHAR. Please understand. When we are discussing about ARM, we use long because ARM is having 32-bit. Okay. Right now, we are going to use 8-bit microcontroller for our learning purpose. Now, what people have done was, they've done a beauty. I have taken a port, 8 bits. I connect 8 LEDs. See here, 8 LEDs I connected. 1, 2, 3, 4, 5, 6, 7, and a dot. It's a dot here. Understand? They put the LEDs like this, but it's a LED symbol, but actually they made it like this, like a tube light. They make it as a bar. They make everything like a bar. All LEDs, they make it as a bar. So don't get confused. Because I've drawn a symbol like this, what you see will be like this, a bar like this. This is called 7-segment display. Nothing. It's not a great one. Same LEDs. Now what they have done, they call this as A. This as B. This as C. This is D. Sorry. This is D. E. F. G. And dot. They call dot point DP. They call DP. Understand? They given a name. And all the pins of cathodes, they've connected together. Connected to ground. They don't connect it, they leave it like that. They give you a pin. Understand? So all the cathodes are connected. Please understand, I have 8. It's like this. Actually, if I draw like this, you will understand. understand like this. Please understand. Please, if you draw like this, you will understand. Or 8 other. So A, B, C, D, E, F, G, H. And all these pins are, of course, they connect a resistor. Please understand. Without resistor, they don't do that. They connect it. Understand now? This is easy to understand. This is what they've done. They call this as a B, C, D, E, F, G dot. Now they have arranged like this. Now let us assume that I want to display 1. I want to display 1. So this is A. This is B. This is C, D, E, F, G. Okay. Now, if you want to display 2, let us take it. Let us say I want to display 2 here in this. Then I don't want to display F, remove F, and remove C, and remove dot. I don't want. What I want now, A have to be displayed. A is 1. B, yes, 1. C, no, 0. D, 1. E, 1. F, 0. G, 1. Dot 0. That point. Okay. Correct. Yeah, if you buy an IC with only 8 pin, you will get only 1 port. If you buy an IC with 100 pins, you will have more ports. That depends on, yeah, it's exactly, you can buy an IC with the number of pins. Same IC with the different pins are available. You're right. That like I'll show you later when I am referring the data sheet. Okay. So I can buy a same 2560 IC at Mega with less pins or more pins. That depends on, but internally the CPU will not vary. Everything will be same. Only thing is number of ports outside will vary, depends on your cost. If you pay more, you will get more ports. If you pay less, you get less ports. That's it. Now, I know that, I know on the 7-segment display, what I have to display now. 0, 1, 0, 1. 1, 0, 1, 1. Hexadecimal 5B. Now I write a program now. I write a program. Star out. Out is equal to 0x 5B. Sorry, first out is equal to, we have to initialize that as 0x 31. And star out is equal to 0x 5B. See, this is easy for you, or you can write in binary also. But generally, people don't write 10 10 10. That's not the professional convention. See, that's the professional convention. So now let me show you as a program, then you will understand. I'll show you on the program on the board with the connection of this, then you will understand. That's a trick. Okay, I'll take a screen. As I mentioned to you that day, I go to the simulator. I go to the simulator and take the Arduino Mega. This is our 2560. This is the chip used 2560. And I just push it up. So easy for me. And we are going to use this port A0 to A7. That is what we have discussed that day about port F. Port F is this. Okay. Now I take the 7 segment. I take a 7 segment now. Yeah, it's there. Okay, I give it here. Now this guy is having, see that pin B, A, common, F, G, E, D, common, C, and dot. The same thing what I discussed on the board. Anyway, I'll share the board now. Then you will see that. So same thing, whatever I displayed, I discussed on the board. ABCD is there on the chip. Now, how I'm going to connect this? The common point I connected the ground here. See that? Now, same thing I'm going to do. I'm going to connect this to the ground. Quite simple. See what I'm doing. I'm just touching the pin. Then go here. Sorry, I've touched some wrong pin. Okay. Then connected to ground. See here. I drawn a small circuit. Finished. Now what happened? I connected the pin to the ground. Now where is A? A is here. I connect the A here to the A0. A0 is this pin. Now I connect B. Just watch it. You will understand. 2 minutes you will understand. That's it. Then where is C? Look for C. This is C. I took C now. You can draw it just like that. It's very simple. Then where is D? Yeah. D is here. Then where is E? It will take some time, fellow. I don't mind. I don't mind spend the time for you because if you watch it, you will understand it. Where is F? Yeah, it's F. Where is G? G. Sorry, I've connected. I connected them wrongly. Let me connect the F correctly. Let me connect the G. I'll share this diagram to you. You can able to do that. And dot. So all the 8 pins, I connected the 8 pin. So whatever I have drawn on the board here, whatever I have drawn here, I made the actual connection. This is the way we connect the circuit diagrams. No. You cannot. These are all standard. These are all standard. ABC are standard. You cannot change the standard as you wish because the chips are manufactured like that. These chips are manufactured. These are all manufactured. You cannot change it. But normally what happened? All these things are coming as a common anode. I'm going to change it to common cathode now. See that? They're available here. There's one option available here. I can change the attribute here. The 7th segment. Within code. Common. Colon. Cathode. See here, now I made it to common cathode. Now let me write a program now. See that. Let me write a program. No, resistors are built into the chip display itself. These displays, they have a built-in resistors. You do not have to give an external resistor at all. They have a built-in resistor. Okay. Now I do like yesterday, I write a program. Now I'm writing now. See that. I'm going to write a program. Volatile. Char star DIR. DIR is equal to 0x30. Star D is equal to 0xFF. I make everything as output. Please understand. Now I go here. I write volatile char star out. DIR is equal to, out is equal to 0x31. I'll once again show you all the connections, then you will understand. Star, first I'll display things. What we discussed, we found 5B. We found 5B here. I write 5B here. So I've written here 5B. Let's make it big. Okay, you'll see that now. I make it slightly bigger now. So this one I connected here. So you'll see that now. So how I've connected this. If you see, for example, I want to remove the wire. You take the mouse there, click it, that wire will be gone. See that? I take the pin, ground, it is visible. I press the mouse, left button. I take here and press it once again. Take it, connect it. See there, it's gone. Okay, it's done. Now let me run the program. So I made it slightly bigger one, so you'll be able to. I hope things are visible to you. Okay, that's why I make it bigger. Now I run it here. When I execute the program, see the 2 is come. Understand now? Now you got a 2. Now I want 3. I want to display 3 now. That means that this has to be on. G has to be removed. Now C has to be 1 and G has to be removed. Sorry, this has to be there. Sorry, G has to be there. E has to be removed. So let me remove E. E is 0. And what is that now? C has come. So 0, 1, 0, 0 and all 1. That means that 4F. Now I write the code here. I write the code here 4F. Am I right? 4F. So I execute now. I stop it and execute. 3. Am I right? You can do anything. This whole thing can be done in a nice way. If you write a good program, I'll show you another program. If you use a for loop and arrays, I can even display numbers or anything. No, basically understand one thing. Don't get confused between the programming and this. So now I'll make all the connection one by one. I'll make all the connections. First connection is this. This board is not your board. This board is designed by Arduino. Am I right? Now, this board, you should know what pin is for what. What is the connection? No, right now I'm discussing 5B. Right now I'm discussing 5B and 4Up. I didn't discuss this the previous one. These are all numbers. This is the character I'm outputting. This is the C programming. The 4F we discussed here. How we got 4F. This is you have to watch the number system videos, which is there in the this one. This is the binary to hexadecimal. This is all there in number system videos. In your directory is there number system videos. Watch them. You will be understanding them. This is a very binary to hexadecimal. That's simple. Of course, yesterday I explained this. Of course, yesterday I explained this. So let us go one by one. This circuit, this board is, who is the board? The Arduino. And yeah, that we will do that. We are not about to discuss input now. When I'm discussing about switch, then we will do that. That's correct. Yeah, we have a thing. We have about actually, to be frank, we have about so many things are there. First thing is LED, up 7 segment, switch, keypad, dot matrix. We're going to do all of them. Please understand. We're going to do all of them. Okay. Yeah, it is visible to you. The board is visible. No, it's not visible. Yeah, it is visible. The board is visible. Whatever I'm drawing, you could see that. Oh, that is small. It's because of there's some problem here. I'll make it this one other way. I'll do one thing. I'll stop this. Then I'll share it. Now you understand. Now you see the board big. Am I right? Yeah, correct. Yeah. It's I know that when you see in mobile, it's small. Okay. Now you see that. Okay, LED, 7 segment. We have LED, 7 segment, switch, keypad, and dot matrix. Oh, is it? Okay, I don't know that. Okay, let me do that. I've never think double tap. I'll do it later. So you understand now. So this right now we discussed 7 segment. Yes, last class we are discussing now 7 segment. Last time we discussed LED. Once you do it thorough, then if you make it these two, if you do practice, but if you're not done it on yesterday, fine. You do it on coming 2-3 days. On Monday, we will discuss about switch. Okay, even though I'm delaying a little bit, I don't mind. I want to make sure that you understand things slightly thoroughly. I don't want it to go in a hurry. I want you to thoroughly understand. If you don't understand this LED, you don't understand 7 segment. If you don't understand 7 segment, you don't understand switch. If you don't understand switch, you don't understand keypad. If you don't understand keypad, you don't understand dot matrix. Understand now. That's why I given a delay of 2-3 days. But even still, that's not sufficient for us to practice. Now I will tell you one by one. This board is designed by Arduino board, like some company. In this case, we have taken the board because this is available for us to simulation. So that's why I've taken this board. And I have yesterday shown you that diagram. What diagram? What is the chip? See, what is the connection between this chip 2560 and the pins? Okay, that is what I've shared the document here. It's here, not this one. Sorry. See here. Okay, this is a document given by who? Atmega chip, Arduino controllers. They are using the Atmega 2560. A0 to A7 or port F to port F7. Forget about this ADC and AC. That's all we'll discuss later. Right now we are looking only for the port. These are called alternate functions. Every pin is having alternate functions. So each connector is having different ports. Now you see here, A8 to A15 is PK. That we have shown everything we have shown yesterday. Now you see here, all these pins are available what port. So we have used this PF0 to PF7. No, this is what the chip, and this the connections are done by the board, the manufacturer. Now they made a PCB and given you. The pins are all PF0 to PF7. So now this chip, I shown you a data sheet. I've compared the data sheet. This called port F is there. Okay. This port F is having 8 pins, which I've shown you already on the chip. See the chip here. The chip, we have seen the diagram. There are port F. See here. These 8 pins. Think about only 8 pins. Forget about other ports. Now you see this. Am I right? Let me zoom it now. Am I right? So the chip pin number 91 is PF6, 90 is PF7, 97 is PF0. This is what on the chip. This is manufactured by the company called Atmel, and the chip number is Atmega 2560. Am I right? There are so many chips. We are talking about 2560. Understand now. This is clear. If this is not clear, please let me know. That is, this chip is manufactured by a company called Atmega. That manufacturer had given the data sheet. In that they mentioned pin number 90 to 97. The 8 pins are called PF0 to PF7. Am I right? Is it clear? If it is not clear, let me know. I'll give you a minute. I'll give you a minute. If you don't understand, let me know. Let us not move in a hurry. Let us make sure that we understand every step correctly. No, if you don't understand, let me know. That's the only thing. Okay. Okay, that is fine. So if you keep quiet, I assume that you understand. Don't tell me later you don't understand. If you don't understand, let me know right now, please. Now what happened? There is a company called Arduino. Okay. Somebody started a company. Forget about that. Who? We don't know who started or not. Somebody started a company called Arduino, like Eastern Academy. Somebody started a company called Arduino. They bought the chip from who? Atmega. Okay. And if you want, I can show you. I can get the. I'll search it here. See that? Atmega. Sorry. Or do you know? Circuit diagram. Okay. This is what the circuit diagram. See that? What they have. This is actually called circuit diagram. I'll make it big. You will know that. Somebody made a schematic of the chip. See here. So this, I'll make it bigger. See, this is what the circuit diagram of Arduino Mega. Now they see that ports are all available here. You go and search. So every port is they connected to the connectors. Like that, they have connected a port F. This is called circuit diagram. So they use the chip 2560 and then they made a circuit diagram. This is called schematics. Now what happened? Using the schematic, what they did was they made a board. I'll show you now also, that also. This one. They made a board. This from Arduino site only, I'm showing the board now. This is what the board. So you see that board now. See here. This is what the board. Okay. Now this is what the connections. All the you see here. When I say A0 to A7, when I say A0 to A7, the chips are connected here. You see that. This is called PCB. They made the PCB and they soldered the IC on this. But if they don't tell you that what pin is what connected, you will not be able to use it. Okay. For that reason only they're given this diagram. This diagram they're given you that, oh, A0 to A7 is connected to PF0 to PF7 of the chip. Because they don't show the connection here. The connections are shown only here. The circuit diagram. This is the board. This is the reverse side or the back side. Okay. They given all dimensions, everything, what chip it is and what is the speed and all this information. Forget about that. So this is what the company Arduino CC, their Arduino company has manufactured this board. Understand? Now they have given these details to you. Finish. Now what we have done, that is what is important to us. What we did was, we have used this board and we have connected a segment. Since I've used this one, let me show this one here. PF0 to PF7, A0 to A7, I've connected that. Is it clear? So I will go to the board now. I'll explain to you what are all the steps. What steps you're supposed to do to understand this. If you don't do this, you will assume. Don't assume, because once you understand on this, the same methodology on every board, whether it is a ARM board or any board, the first thing is you go to the chip. The chip, they have so many ports. So the chip, they make a board. Chip becomes small, part of the port. And they have the pins, such a way that you can take them out. You can connect the connectors. This is called port. And they connect it here with the chip. This is called PCB, printed circuit board. Now they will show the diagram. They will show a diagram mentioning that which port is connected to which connector. Which connector. So you have one connector called, let us say C1, C2, like that. So each connector, that is 8 pins, each port, what port it is. That now using that, let us say this is port F. You have done now. Now you know that. Now what we did was we connected the 7 segment. We connected the 7 segment to the port F. Done. A to bit 0, A to bit 0, and bit F to dot. We have connected. That is A, B, C, D, E, F, G dot. Then 0, 1, 2, 3, 4, 5, 6, 7. That's it. This is the way we connected the port. Now it's done. Now your wiring is done. Your wiring is done now. Now you have to go to another document called data sheet. In the data sheet, they will tell you that the port is having what is the address for direction, what is the address for out, what is the address for in. Now in this case, port F, the direction is 0x30, out is 0x31, in is 0x2F in this port. What we did was, we have used this information, we wrote a software. What software I wrote was this. Wrote the software, CAR D, CAR out, because we're going to use only out now. I'm not bothering about in. Next session, on Monday session, I'll explain about input switch. Now, please do one help. Before Monday, practice this. This does not require anything. Dir out. Now I say dir is equal to 0x30. Star dir is equal to 0xF. That means that I make every port as output pin. So I configured now. That's why I write into the setup. Now I will say out is equal to 0x31. Star out is equal to whatever you want to print. Let us say I want to display only 1. I want to display 1. That means that all the others are not there. The 7 segment, I want to display 1. So this is not required. Nothing is required. Only B and C has to be required. That means that A, B, like that, in that ABC. Let me write it here. It's very clear. I want only B and C has to be there. So B is 1, C is 1. A is 0, D, E, F, G dot. All are zeros. That means that if I write 06, I will get 1. I will get 1. No, you do not have to input anything. Not required. Because we are not using printf or anything. We are not using any functions. That is advantage here. We do not use any of the Arduino functions. We are using a microcontroller. That means that this is going to be useful for you, ARM. I can show the same thing in ARM also later. Nothing. Once you understand this, I can explain the same thing in ARM also for you. This is common for all the microcontrollers. That is what I'm trying. So understand the flow. Understand this methodology. This is the methodology the companies expect. This is a methodology every company expect. Every company, if you start write the program, they will understand that you know embedded system programming. This is all about embedded system. Now let us go here. I will write the 06.
Sir.
Yes.
But sir, in previous class, you have included the ECN.h.
No, I have it, but you can avoid it now also. If that is text also, you can use it. If you want ECN.h, you can use it. If you don't want it, you can do that. I wrote it for myself to show you that it's possible. You can use without that also, you can use it. You need to use that. Okay.
All right.
That I just wanted to show you that how to use the out and in. Okay. Now I see here, I put here 06. Then I run it. See, I get 1. Understand? Things are very simple. Don't make it complicated. So let's take a break for about 5 minutes, then come back. I'll discuss about some more interesting topic about this 7th segment. There's some more is there. Okay. So please understand the flow. Let me leave the board as such. Let me leave the board as such and try to understand the board. What is there on the board? And this I can share you. If you want, I can share this one. I'll do one thing right now. Share. I'll save it as a. Seventh segment. Okay, I saved it. Share it. Yes, sir. No wonder I'll do that. Otherwise, later you may say that I may forget and you may not get it, which I don't want. This is the advantage. This is the advantage here. When I do the thing, I can share you immediately. You'll be able to see that. Okay, you got it now. Am I right? You have got the. So let's take a break for about a minute. I didn't understand the last question. What is the PR, the output? No, I'm not getting you. The output is shown here only on the display. I'm sharing the screen. You watch the output now. You can buy the board and numbers are there on the 7th segment. You see a 7th segment display now. You see a display now, or you don't see that? The screen, do you see a display? Anybody, please? I'm sharing the screen and you must see a display. Yes, yeah, you're seeing a display now. Okay, I'm going to run the program and the display will be showing whatever number it is. Yeah, I'm showing on the display. Yeah, I'm showing it on the 7th segment display. That's what I've connected and wired everything now. You can display any number here. If I put 7F, it'll display 8. All the 8 digits will be shown here. Now you see that. 8 will be displayed there. See here. You can display anything on this. If you want, I can make that one as a much bigger. Yeah, now it is fine. Am I right? Once you know the connection, then I can show only display big. That will be easy for us to understand it. Oh, That is what I explained from the class from beginning. Okay, let's take a small break. Okay, I'll come back.